Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at initializer lists in C++11. So I think in the last tutorial I referred to initialization lists, but really we should keep that terminology for the constructor syntax that we're already familiar with in C++98. This is not an initialization list, but strictly speaking an initializer list. Although I've seen the two terms being used interchangeably, but really that's a bit ambiguous, so we should call this an initializer list. So an initializer list in usage can look, for example, like this. So this only works if you enable your compiler for C++11, and of course it must support C++11. And we can initialize vectors with this wonderful syntax here. Now we can actually use that in our own classes. So let's create a class called test here, and so what I'm going to do here is I'll show you how you can actually pass values like this to the constructor, and I won't actually use them for anything for the moment, but I'll give you an exercise a bit later on. So let's create a public constructor here. Now to get this to work, we need to include up here initializer list, so initializer underscore list, and we need to be using the standard namespace, and then we can make this constructor take an initializer list as an argument, so initializer underscore list. That's a template type, so we need to say what kind of type of thing we should use to initialize this. So let's say, for example, we want to be able to supply a list of strings to this constructor, and then let's call this text like that. So now when we create this class, we can say test, I'll call the actual object test with a lowercase t, and we can supply strings in here like this. Yeah, sorry, not like that. with brackets. So let's put in curly brackets here, and put in apple, orange and banana. Now, how do we actually access the values in this list in the constructor? Well, you can do that using, this is actually iterable, so we can use iterators with it, and we can use even for with it. So we can say for auto value in text. It's going to be, auto is going to give us a string in this case, we hope, and we can output value like that, and we can see that this syntax successfully passes values into the initialize list, which we're then iterating through. So if we run this, we see that when we construct this test, we've now got this iterable initialization list filled with these values, which we can iterate through. And if we have some sort of complex type that stores data or whatever that we want to initialize this, of course, at this point, we could store it in whatever way is appropriate for our application. What's even more amazing is that we can even use this with functions. So let's have a function void print. So again, I won't actually store anything, although that perhaps will be a more common thing to do. Let's just say here that the type of print is initializer list, and you could use this with your own sort of custom types as well, of course. Let's say, for example, that it's, well, we'll use a string again, but it doesn't have to be string. It could be int or whatever you like. And let's just call this maybe list or something, or maybe just even L, because list is ambiguous. Well, I don't really like L because it looks like a 1. Let's use text, and again we could just iterate through that. So for auto, I'll call it value again in text, then cout value. So how would we actually call this constructor? Well, this is actually something that I wanted to be present in C++ for a long, long time. Sometimes you kind of just really wish you could pass an array to a function without having to declare the array first. And many other languages allow you to do what I'm about to do. So if you do print, now we can pass in here just curly brackets like this, and we can pass in some values, so like 1, 2 and 3. Let's have 4 as well, just to show that you don't have to have 3 items in there, of course. So if I run this now, print's actually going to print out 1, 2, 3, 4. Just by using these lists, these brackets directly in here, we can pass in an initializer list, and then we can access it and do what we want with it. So this is really amazing, and this has been missing from C++ for a long time, until 2011, and you can only really appreciate how amazing it is if you've repeatedly written programs and wished you could do this but you couldn't, and now you can. So if you want to practice this, one thing you could do is, a few tutorials ago we implemented this ring buffer class, and you could try retrofitting it with this kind of initialization syntax, so that you can initialize the ring buffer with a constructor like this. And you could also give it a method that allows you to add values to the ring buffer, let's say, or lets you set the values in the ring value. So that might also be something that could be worth having in there. And either way, whatever you do, definitely worth practicing this. And if you've been doing C++ for a long time, I'm sure you'll be eager to have a go at this, because it is absolutely wonderful that we've now got this in C++. Okay, so that's it for this tutorial. Until next time, happy coding.